All right. There's a saying in chemistry that says, don't trust the chemist that can't cook, which is a little bit ironic because I'm not a very good cook. So maybe you shouldn't be trusting me, but you don't have much other choice. Anyways, the reason that it says that the saying exists is because there's a lot of similarities between cooking and chemistry. So, for example, in cooking, maybe you have some kind of recipe where you're going to take two pieces of bread, one slice of cheese, and just make the world's saddest sandwich. Right. So we have our kind of recipe there. And if we, say the recipe in layman terms, right, you would just say, to make a sandwich, you put one piece of cheese in between two slices of bread, right? Nothing too complicated there. You just go out, you get two slices of bread, one slice of cheese, and you go ahead and make yourself a sandwich. Right, chemistry, we have a similar thing. Instead of a recipe, we have a chemical equation, which we'll take a deeper look into later. So, for example, we could combine some oxygen and some hydrogen. Remember, these are both diatomic gases, so they exist as atoms, two atoms attached to one another, and you make some water, right? And so then in layman terms, what we could say is to make two molecules of water combine one molecule of O2 and two molecules of H2, right? We could even draw our Lewis structures here to think about what kind of bonds are being broken, what kinds of bonds are being formed and whatnot. So you've got your two atoms of O2, two atoms of H2, and then you combine them to form two atoms of water. All right, so this is kind of where the analogy falls apart a little bit, right? In the real world, we can go out in our cabinet, we can grab a slice of cheese, two slices of bread, no problem. However, also in the real world, can we do the same thing with molecules? Can we pick out one molecule at a time? Right? If I told you, hey, go get me a molecule of water, can you do that? There's no way you could do that. And so that's where we run into a big issue, and where the analogy breaks apart a little bit and chemistry gets a little bit more difficult than cooking, right? So these atoms and these molecules are just incomprehensibly small. I mean, they're just absolutely tiny. So anytime we deal with chemistry, we are dealing with huge, huge, huge numbers of atoms, which just makes the math a little bit trickier and just makes it conceptually a little bit more tricky. So for example, one drop of water, which is not a lot at all, contains 1.5 sextillion molecules of water. And that's 1.5 times 10 to the 21st, right? So if you wrote that number out, you would do 1, and then that 5 counts as one of them, and then 20 more zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? And then you can add your little commas. And you can see that this is just an absolutely huge number. And all we're talking about is one drop of water, right? So molecules are just super tiny. And so anytime we deal with molecules or anytime we talk about chemistry, we're always talking about dealing with a whole lot of them anytime we use them in a practical application. And so we just have to be comfortable with talking about dealing with large quantities of stuff.